Well, hello everyone, and welcome to Plant Planet, the efficient future. Next, we're going to hear from Joshua Marshall of Topcon Positioning Systems, where he is a strategic and OEM account manager. He's going to talk about the SmoothRide workflow. That's Topcon's exclusive non-optical 3D paving machine control solution. Welcome, please, Josh Marshall.
Hi, welcome to Topcon. My name is Joshua Marshall. I'm the Business Development Manager for Topcon Positioning GB, and I look after the Paving and Compaction division. I'd like today to talk to you through a couple of products, ranging from 2D to 3D and our non-optical solution that we're offering into the market. So in the paving division, we can offer a variety of different products to suit different applications. 2D machine control is probably the most common in the market to date. So from sonic trackers to anywhere up to laser receivers. LPS is probably one of the most common 3D machine control products in the market for paving. We also offer that here at Topcon. LPS GPS is a hybrid of both options between LPS, so total station, and GPS. Single millimeter GPS, which is an exclusive product here from Topcon. Dual millimeter GPS, which is also again an exclusive product from Topcon. And SmoothRide, which I'd like to talk to you today. That's also an exclusive product from Topcon. For those who don't know, 2D machine control is a common product in the UK, and it consists of most commonly a 2D sonic tracker. And the sonic tracker references to the ground and controls the toe point of the machine, adjusting the level. And this is an automatic machine control solution. LPS machine control, which is via total station, which is the most common 3D choice in the market at the moment. The problem with LPS machine control is the surveying aspect, not only during the paving or milling operation, but also during collecting the data. It means that someone has to be on site during the paving operation and also during data collection with a total station, so during live traffic. The optical 3D solution via total station is on the left and the non-optical solution is on the right. So we use GPS position. And then 2D, it's a hybrid option between 2D and 3D. The non-optical benefits are no requirement for a total station on the job site. No on-site surveyor needed. So it means that we remove less employees from the site and in between heavy plant. So normally during the paving operation, someone would have to be behind the paver with a surveying kit to verify what the paver is actually laying. We remove all that. Limited setup of equipment, so there's no need to set up the total station equipment, all the equipment on the machine. Everything stays on the machine, and then we would just turn the machine on the start of the shift. And as long as we have a GPS signal, everything works with the conventional paving method. Also works better in different weather conditions and at night. So one of the issues with LPS and optical equipment is it has to have line of sight, and also it during wet conditions and cloudy conditions, it limits the accuracy of the paving and milling operation. Removes the total station range and obstruction issue. So a total station and an LPS operation has to have line of sight, and also there is a range to a total station. So if we have an obstruction issue, it can cause issues for the machine. So we remove all that with SmoothRide. No specialist training required. So this is for the operators that are on site. There's no specialist training needed. As long as we have a GPS signal, everything works alongside the conventional paving and milling operations. We have an OEM integration. So we have an OEM integration with Wirtgen at the moment. And that allows us to be able to take control of the screed width, take control of the depth that we are milling or paving. And also it allows us to take control of the steering. So we can allow other operators on the paver or the milling machine to do other jobs, other operations, whether that be just to keep them out of harm's way off the site, or whether that means to allow them to do other jobs on the job site, operating other bits of plant, which allows us for sort of semi-autonomous paving. And I can talk to you a little bit more about that further in the presentation. So really for us, what are the benefits to profile planing and profile paving? We get a smoother road for the road owner. So they get a smoother what we call IRI, which is International Roughness Index. And that removes extensive pressure to the asphalt, causing an irregular surface. And increases the lifespan of the road. So if we can increase the smoothness, it's less pressure and less wear on the asphalt, and it's also less wear on the vehicles that are traveling over it. Strategic planning. So scanning can be done without road closures and at night. And I can talk to you a little bit more about the process and what we can offer. Scan data allows for analysis of current condition of their strategic road network. So scanning can be done in regular intervals, so we can see deterioration of roads, and we can also see potholes, and we can also then create a strategic resurfacing plan based on factual data. So rather than ripping up perfectly good roads, we can put a strategic resurfacing plan together so that we can target specific roads that need to be resurfaced. The environmental impact, which is something that's extremely important to everyone at the moment, which removal of unnecessary resurfacing waste or surfacing waste. So, as I mentioned, a strategic resurfacing plan means that we can target areas that need to be resurfaced and leave areas that are perfectly good. Material is precisely calculated while still meeting requirements. So profile planing allows us to save material in areas that we need to, and that's including with improving IRI and the lifespan of the road, and reduces remedial work. Once the data is collected, there is no need to revisit site for analysis or design. So once we've collected the data, and the collection of data is fairly straightforward to do, there's no need to revisit the site. We have all the information that we need. Scanning can be completed regular to monitor the existing surface. So we can look at the existing surface, we can monitor it. So the benefits to the surfacing contractor, and first of all, improvement of efficiency and quality. The scan data allows contractors to work with their clients to achieve the best outcome. Accuracy of calculated mill and fill quantities. So as you'll see later on in the presentation, the software allows us to calculate mill and fill quantities accurately. Paving at consistent thicknesses to increase compaction results. So the copy paving that I'll talk to you a little bit further in the presentation. Automated variable depth milling and paving improves the end-to-end quality of the product. So that allows us to, once we have profile plane, to lay nominal thickness, or as some contractors are not able to be in control of the milling operation, variable depth paving can improve IRI, but improves the overall quality. So compliance, the data captured during the workflow proves the increase in quality. So as we run through the SmoothRide workflow, the data that's been captured can be produced for BIM or as-built, and that's all almost for free inside the package. and I can explain a little bit more to you about that. Safety, so the reduction for employees on site, which is a key perspective for the safety. No employees trapped between plant, for example, between the paver and the roller. So conventional 3D needs someone to be in between that paver and that roller, which we want to reduce and remove. So for the consumer, that's all of us, everyone that drives on, whether it be a Highways England strategic road network or whether it be a council road. It's a smoother driving experience, a safer driving experience. There's been multiple occasions where IRI is taken to a dangerous level on some of the strategic road network, and we want to be able to remove that. Improved MPG or distance for electric vehicles, which is something that Highways England are severely keen to promote and push, is that, you know, electric vehicles are a lot more common now on our roads, and they want to be able to get the most miles per charge. And one of the prime factors is improving the RRI or the smoothness. Less wear on the vehicles, less wear on the suspension and the drivetrain. Less road closures, which is a key point. Our workflow allows us to collect the data during driving speeds, which means that there's no need for road closures. And a cleaner approach on the environment, which is a key part for, I think, most people in the UK. More value to the taxpayers' money. And I think that comes from primarily the resurfacing structure and the resurfacing drive. We can plan and schedule this work all during the data collection phase. So what is SmoothRide? SmoothRide is a workflow. So it starts from data collection to design to milling or paving, compaction, and then back to scanning. I've just got a quick video that I'd like to run through.
The first requirement is to get an accurate depiction of the road surface. Our road surface scanner gathers a precise map of the entire surface at normal highway speeds, collecting the data you need with more information than a survey crew could provide. The next step is to create a design that meets the tolerances and specifications required. Optimizing and customizing the millions of data points necessary for creating your design file is made easy with Magnet Road Resurfacing software. Once the design is created, it is sent directly to your equipment, allowing milling and paving to begin almost immediately. Equipped with our 3D machine control, the milling machine knows its position on the road at all times. With automated, variable depth milling now a reality, you can now mill to the exact depth necessary, creating perfect mill-to-fill optimization and the smoothest surface possible for your paver to follow. Material costs can quickly turn profit to a loss. Paving with SmoothRide assures rideability while eliminating waste and cost overruns. By managing your material properly across your entire project, you'll never be too thick or thin. Utilizing the same job files generated for your milling and paving machines, operators know exactly when and where to compact, which prevents over-compacting and increases efficiency. Advanced temperature sensors inform the operator exactly when to begin, and the touchscreen control box keeps track of how many passes have been made. As your compaction processes are in action, your rollers are gathering as-built data on the road surface. As more DOTs require intelligent compaction standards, SmoothRide will keep you miles ahead.
So that's just a quick overview of what SmoothRide is in the workflow. So as we've mentioned, it's a hybrid between 2D and 3D machine control. So we use GPS antennas to get the position of the machine, and then we use 2D sonic trackers to be able to get the height or the depth. So the scanning operation, we use what we call our RDM1 scanner, and that's an exclusive product from Topcon. And our RDM1 scanner is a LiDAR scanner that is GPS overlaid, and it collects millions of data points, which gives an accurate scan of the existing surface. So we can scan at 80 kilometers an hour, which is about 50 miles per hour. And that can be done in lane 1, lane 2, and lane 3 of a motorway, for example. So we can keep up with traffic, and our data that we collect can be automatically filtered to remove out things like passing vehicles. And whilst we're collecting that data, the ideal, our data and our software that collecting allows you to see a really good picture of the data that you've been collecting. So if you miss a particular point or you miss a particular spot, you can go back around and collect that data again. So out of those millions of data points that we collect, we create what you call a DTM, which is a digital terrain model. And that digital terrain model, we then create a design. And from that design, that goes directly into the milling machine or the paver, depending on which is the most likely option for the client or the contractor. So once we have that milling operation or that design, we do what we call variable depth milling. So it allows us to create a completely flat surface ready for the paver to then lay a nominal thickness over the top. And it's becoming very, very desired in the market. Once we've variable depth milled, we can then scan the existing surface again, so the milled surface, and go back with SmoothRide paving. Or, as I mentioned, sometimes the contractor cannot always be in control of the milling operation. We can scan the existing surface, whether it be an undulated surface, and then we can variable depth pave back, which is very similar. We get very similar results, if not better than an averaging beam. And all this time, because we have the existing surface, our software allows us to tailor the requirements so that we don't overcompensate on material. And as mentioned in the video, once we have the data that's been collected, we can put that also into the compactor, and the roller will then say exactly where to compact and where not to compact to meet the full requirements. Then once we've produced the existing road, once we've produced the new road, we can go back and scan for the as-built. So I'll just give you a quick run through of our RDM1 scanner. And the RDM1 scanner produces a point cloud, which is all fully GPS overlaid. And that is the point cloud that's produced. And as I mentioned, we put that into a DTM. So that's the DTM from that point cloud. And then we put that into our Magnet Office resurfacing. And our Magnet Office resurfacing is a really good software. It gives you plan view, profile view, and more, cross section, which is really important to be able to look at cambers, water drainage, etc. And all the time that you're making these tweaks and these specifications, in the bottom left-hand corner, you can see the volume calculation. So every adjustment that you make to the milling or paving design will change that volume calculation. We can set limits. So from certain chainage, from chainage A to chainage B, we can set minimum and maximum thicknesses. So what the operator wants to mill, or what the operator wants to fill, or the contractor wants to fill. This is massive for minimum depth requirements, and this design and this process can actually prove minimum depth requirement, and what's able to be offered, and make sure that the contractor meets the client's specifications. So we can offer cross slopes and cross falls as well that can be automatically milled or paved via profile planing or profile paving. So if we have a particular area where we want to change the camber or the cross slope of the existing road, we can do that all in the software. And as I mentioned, once we've done the milling design or the paving design, we can then move straight onto the report. So we can get a mill and fill quantity report that can go either to the contractor or the client. And it allows us really to be able to offer to the contractor or the client the right specifications to the right tonnage. If there is an issue with the existing road, and the contractor doesn't know about it, when you take the scanner out and you scan that existing surface, we are able to explain without visiting site what the issues are, where the issues are, and what we need to do to change it, whether that be more material, whether that be a change in the client specifications, and we can do that without even stepping foot onto site, which I think is a massive benefit to the client and the contractor. So really that's all from Topcon on the SmoothRide. Thank you very much for listening, and I will be at the conference, and I look forward to answering any questions you may have. Thank you.
Joshua, thank you very much. Let's take some of the questions that are already in the Q&A box. This one from a participant who hasn't shared their name with us. How many projects in the UK civil sector is this in use?
Thank you very much. Yeah, we have used SmoothRide on multiple projects across the UK. Two that we've done recently. One of them being, the first one that we did with major was Silverstone Racetrack, and we fully profile planed with tarmac and an RP. And then we've done two recent projects, one of them being an airport, and then the second one being a specialist test circuit. So yeah, that we are using SmoothRide on a variety of different projects across the UK.
Silverstone's a pretty decent high-profile example to quote.
Yeah, very, very good.
Which leads to the next question, which is, what is the accuracy of the workflow? If you're doing it for F1, you've got to be good.
Yeah, there's a certain different variety of workflows that we can do. Some that can be even tied with GPS accuracy is limited, and we can work around the GPS accuracy by a different workflow, and we can get it as accurate as total station. It requires a little bit more work and a little bit more survey aspect to create certain profiles and certain localizations. But once we do that, we can stake out to as a verifiable via total station, which is a really good result.
Okay, Joshua, thank you very much for sharing your thoughts with us today. Now,